Okay, everyone, so our next topic is something called vectors. Now, you're probably like, vectors? What does that guy from Despicable Me have to do with physics? If you remember from the movie, Vector, the villain, is a villain who's committing crimes with both direction and magnitude, because that is what a vector is. A vector is a quantity with both direction and magnitude. So direction is super duper important. Now, if something is not a vector, it is something called a scalar. So scalars are things where the direction is unimportant, okay? Now, thing about vectors, we already know a few. If you go back to your notebooks from a couple weeks ago, when we were defining position and distance and all of that, there are a couple things that were already starred. The reason I had you star them is because they are vectors, okay? So, vectors that we know displacement, we know velocity, and we know acceleration. All of these things are vectors, meaning the direction is super duper important. Scalars we know, distance, speed, time. These scalars just have magnitudes, meaning they just have a number, they don't have a direction. Okay, now, another thing that Vector our villain said is that it's a mathematical quantity represented by an arrow. So if I draw myself an arrow, okay, this arrow is a vector. Okay, technically it's a ray because it only has an arrow on one end. But the magnitude of the vector, so the size of that vector, is going to determine the length of my arrow, and the direction it's pointing is going to tell me the direction of the vector. Okay, now in this class, we are going to deal with directions in terms of angles, okay? We are also going to talk about directions as positive or negative. So, we need to make sure that we are on the same page about directions, okay? So, there are a few conventions in physics, okay, and in math that we're going to apply here. So, just so we are all on the same page, okay, if I ever say an arrow is directly up, that's north, directly down is south, left is west, right is east, okay? I've learned it as never eat soggy waffles, but I know there's a couple other ones out there. If we want to be more specific, so if I'm not just saying, oh, it's northeast-ish, if I want a number attached to it, again, we're going to add that angle. So, okay, we're going to talk just like in math class, okay, we're not going to deal with radians. Directly to the right is 0 degrees. Directly up is 90 degrees. Then we got 180 and 270. So let's say I say there is a vector and it is 300 degrees, okay? That would be over here in quadrant 4 somewhere, okay? So we're going to make sure that when we give angle measurements, we're having the conventions between 0, 90, 180, and 270. So let me give you an example why vectors are important. Okay. So let's say I'm going to walk 3 meters east, then 4 meters north. I want to know two things. A, what was my distance traveled? And B, what was my displacement? So let's just draw this out really quickly. So I'm going to have, okay, 3 meters east, and then I'm going to go 4 meters north, okay? The distance traveled is that 3 plus that 4. It's going to be 7 meters for my displacement, or for my distance, excuse me. Displacement is the overall change in position. So my displacement is not 7. My displacement's only going to look at the beginning and the end. So we need to figure out a value for that hypotenuse. Now, you might remember 3-4 triangles from math class, but in case you don't, what we're going to do is we are going to use the Pythagorean theorem. A squared plus b squared equals c squared, where c is that hypotenuse. So c becomes the square root of a squared plus b squared. Okay, so it's the square root of 3 squared plus 4 squared. And again, we're gonna get 5 meters. So 5 meters is my displacement. But here's the thing, I'm not quite done yet. Vectors need a direction. So I need to figure out what that angle is, right here, that angle right there. Now, I don't know if you remember in math class, the symbol I'm gonna use for angle is this theta. It's a Greek letter, okay? And we need to figure out a value for that theta. And so I'm gonna remember SOHCAHTOA, okay? I'm gonna use tangent. And I'm gonna say tangent of theta equals my opposite over my adjacent, okay? And I'm gonna solve for theta. So theta equals inverse tangent of opposite over adjacent. So theta equals the inverse tangent of 4 over 3. Now, it's really important when you're plugging this into your calculator that you are in degree mode. I understand in math class you might be in radian mode. You gotta make sure you're in degree mode and for physics. So you're gonna plug that in, and you get 53.13. So my overall displacement is 5 meters at an angle of 53.13 degrees.